Satyendra Bose. Satyendra Bose is considered to be one of the great Indian theoretical physicists known for his work on quantum mechanics. His area of research was the theory of relativity. Yes, the same theory of relativity that we know, which was researched by Einstein himself. In 1924, Bose derived Planck's quantum radiation law in a paper without reference to classical physics. This paper proved influential in the creation of a new field called quantum statistics. Particles with integer spin came to be known as bosons. Repeat, particles with integer spin came to be known as bosons. The Higgs boson particle, more famously known as the God particle, is one of these many bosons. The name boson was suggested by Paul Dirac in Bose's honor. Bosons are particles that obey Bose-Einstein statistics. Bose passed with an MSc in Mixed Mathematics from the Presidency College in Calcutta in the year 1915. One of his teachers at the college was the eminent scientist Jagadish Chandra Bose, or famously known as J.C. Bose. Bose sent this paper in a letter to Albert Einstein in Germany. That is, the paper that he wrote, or he derived the Planck's quantum radiation law, that same paper was sent to Albert Einstein in Germany. Realizing the importance of this paper, Einstein translated it into German and published it on Bose's behalf in a prestigious German journal. The paper was named Planck's Law and Hypothesis of Light Quanta. This recognition enabled Bose to work in Europe for 2 years alongside great scientists like Louis de Broglie, Marie Curie, and Einstein himself. Einstein adopted Bose's idea from the paper and applied it to atoms. This caused the prediction of a phenomenon which was later called the Bose-Einstein condensate. Apart from physics, Bose was also interested in biotechnology, geology, zoology, engineering, anthropology, and literature, both English and Bengali. Bose was appointed advisor to the Council of Scientific and Industrial Research after it was formed. He was also appointed the president of the National Institute of Science, the Indian Statistical Institute, and the Indian Physical Society. He was also made the general president of the Indian Science Congress. He was nominated to the Rajya Sabha. In 1958, he was made a fellow to the Royal Society. Bose was awarded the Padma Vibhushan in 1954. He was nominated for the Nobel Prize as well. Now let's know more about the Bose-Einstein condensate. First, about the matter, atom, and molecule. Matter is the stuff that makes up this universe. Or simply said, anything that takes up space and has mass is called as a matter. All matter is made up of atoms, which are in turn made up of protons, neutrons, and electrons. Atoms together form molecules, which are the building blocks for all types of matter. Both atoms and molecules are held together by a form of a potential energy called the chemical energy. There are 4 natural states of matter: solids, liquids, gases, and plasma. But there is also a 5th state, and that is the man-made Bose-Einstein condensate. This exotic material only exists when atoms of certain elements are cooled to temperatures near absolute zero. At that point, clusters of atoms begin functioning as a single quantum object with both wave and particle properties. That is, the cluster of atoms joined together become a single quantum object, and that object will have both wave and particle properties. Bose-Einstein condensate was created by scientists in 1995. Using a combination of laser and magnets, scientists cooled a sample of rubidium to within a few degrees of absolute zero. At this extremely low temperature, molecular motion comes very close to stopping. Since there is almost no kinetic energy being transferred from one atom to another, the atom begin to clump together. We want atoms to clump together to form a single quantum object, as we said right now. And these group of atoms are no longer thousands of separate atoms, but just one superatom. The Bose-Einstein condensate is used to study quantum mechanics on a macroscopic level. Light appears to slow down as it passes through the Bose-Einstein condensate, allowing scientists to study the particle and wave paradox. A BEC also has many of the properties of a superfluid or a fluid that flows without friction. BECs are also used to stimulate conditions that might exist in black holes. And why is it easy to create a BEC in space? BECs have been produced in a variety of experiments on Earth since 1995, but these are hindered by gravity, which collapses the clouds in a split second. In the near zero gravity in space, they can mix the ingredients in a much smaller catchment called as a trap. On Earth's surface, the atoms begin to repel each other and fly apart almost instantaneously. On Earth, laboratories can only maintain Bose-Einstein condensate for a matter of milliseconds. However, researchers at the ISS, or the International Space Station, have created a Bose-Einstein condensate that persisted for more than 1 second. Now let's talk about the Higgs boson, or famously called as the God particle. The standard model of physics hypothesized about Higgs boson in 1964. The discovery of Higgs particle was announced at CERN on 4 July 2012. The discovery appears to confirm the existence of the Higgs field, which is pivotal to the standard model and other theories within particle physics. And let's see the relation and also the differences between the field versus waves versus particle. A field is normally made up of waves, and a wave is made up of particles. The least intense possible wave that a field can have is called a particle. Applying the concept in Higgs field, Higgs particle is the smallest Higgs wave, and the Higgs wave is a ripple in the Higgs field. And why this Higgs field is so important? The Higgs field has a non-zero average value, and because of this, many elementary particles have mass. And also remember that the electric field has zero average value, and that is why it does not have a mass. The discovery of Higgs field would explain why some fundamental particles have mass, but the symmetries controlling their interactions should require them to be massless, or in simple words, you add 2 plus 2, it comes out as 5. And where does that 1 come from? That is what the discovery of Higgs field explains us. The Large Hadron Collider, famously called as the LHC, was built to figure out what the Higgs field is and how it works, and whether it is elementary or composite. In fact, the LHC was built to do much more than discover the Higgs boson, such as identifying the dark matter, search for extra dimensions of space and microscopic black holes, look for signs of unification of fundamental forces, find evidence for string theory, find the Higgs boson, understand antimatter, learn about the fundamental forces that have shaped the universe since the beginning of time and will determine its fate as well. Mass of ordinary matter is mostly from the atomic nuclei. This mass does not come entirely from the Higgs field. The Higgs field gives mass to most of the elementary particles but not to bigger composite particles. This means even if there is no Higgs field, there would have been protons and neutrons, which of course have mass. The Higgs particle itself gets its mass, at least in small part, from somewhere else, and we guess it to be the dark matter. Now it is true that the W and Z particles, the quarks, the charged leptons and the neutrinos must get their mass from this Higgs field. The massless particles are photons, gluons and gravitons. So as we are talking about all those particles that have mass and where do they get this mass from, we also have to know those particles which do not have mass, and they are the photons, the gluons and the gravitons. The standard model of particle physics hypothesized about this Higgs boson. In fact, this hypothesis states that the Higgs field is made up of elementary particles called Higgs bosons. So now, related here, Higgs field is said to give mass to the elementary particles. And what is this Higgs field made of? It is made of Higgs bosons. But in reality, there might be more than one Higgs field made up of particles other than Higgs bosons. So, the suspect here is, so what is the doubt here is, there might be more than one Higgs field. And they might be made of particles other than Higgs bosons too. So Higgs field, we know now it is made of Higgs bosons, but maybe in future we might discover other particles apart from Higgs boson which are also part of Higgs field. That's it for today. Thank you.